Welcome back to a video on polynomial functions. So the video here is going to cover different types of functions and what their graphs look like. And some of the stuff that we're going to do here is going to go back old school and just tie some stuff into what we did in previous chapters. But it's pretty important to talk about these. So we're going to talk about different types of graphs. And it's based on, a lot of the stuff is based on their exponent, also known as their degree. So this one is a linear function. It's a x to the first power. The degree of the exponent is 1. This is degree 2, but that would be called a quadratic. A third degree polynomial is called a cubic. A fourth degree is called a quartic. A fifth degree is called a quintic. But those are the types of graphs we're going to be working. Like polynomial functions, we can work with any degree. So a few things I want to talk about before we move too far is what the basic shape looks like and some of the hints you can get from it. So one of the things I want to talk about first is odd versus even. 1 is odd. 3 is odd. Notice it goes down to the left, but goes up to the right. Same, look at, starts low, finishes high. And now let's go look at an even graph. An even graph goes up in both directions. Here's another even graph. It goes up in both directions. So they have a lot of similarities if they're even or odd. And that's going to be especially helpful when we get to end behavior. So they're going to go in the same direction if it's an even function, but they'll go in different directions if it's an odd function. And of course, we can make these negative too. So that would be a negative x. This would be a negative x squared. So we know before multiplying by a negative just reflects it over the x-axis. So they're going to change directions. If we were to multiply this guy, that would be a negative x cubed. This would be a negative x to the fourth. So, but as you can see, the end behavior is still going to go in the same direction if it's even, and it's still going to go in opposite directions if it's odd. And I guess the last thing we want to talk about for now is possible solutions of each. Possible doesn't mean the absolute number. It just means how many are possible. We've discussed before that if you just graph a line, it's going to intersect the axis once. So possible solutions versus possible terms. Possible solutions is the degree of the function. So x cubed has 3 possibilities. X to the fourth has 3 possibilities. Sometimes there's only 2, but there could be up to 4. The possible terms is the degree minus 1. So notice a linear graph doesn't turn at all. It just keeps on going. But a quadratic, it goes down and then it turns the corner and comes back up. A cubic starts by going up, then it comes back down, and then it goes back up. So as you can see, those are turning points. Those are known as local maxes and mins, also known as extrema. So that was a lot of information right there about different types of polynomial functions. However, you may or may not know this. You already know how to do almost all of it. So we're going to do some examples on a given graph because your graphing calculator will find all of these for you. So the first thing is this one going to be even or odd? This is an odd function. Now that's going to be important when we get to describing the end behavior, because there are going to be ways for you to do the end behavior without even needing to look at a graph. So it's an odd function. What are X-intercepts? We have one at -6, 0. We have another one at -2, 0, and another one at 2, 0. Now notice, this is an x cubed. It has 3 possible solutions. There they are, -6, -2, and 2. Those are your 3 solutions. Your y-intercept is still where it crosses the y-axis. So this is 0, -2. But now we're going to talk about some local maxes and local mins. That is your turning points. Now, obviously, this one goes down forever and ever and ever. And this side goes up forever and ever and ever. So you don't really have a max or a min, but in this location, just in this region, -4, 5 is one of your turning points, and it's considered a local maximum because it's at the top of this region. Your local minimum would be 0, -2. It's the same as the y-intercept, which is not always the case. It just happens to be for this example. And that's because it's the bottom of this location. So those are local maxes and local mins. The other stuff that you already know how to do is increasing and decreasing intervals. So now you just might have more than one section of increasing. So remember, we always start from -infinity. And if we start in -infinity, the first thing we do is increase. Now remember, this is in terms of x. So we already found our starting. We start at -infinity. Where do we stop increasing? We stop increasing at one of your turning points. At this case, it's -4. Okay? And once we get to the top at -4, and if it helps, you can actually split these into regions. We're going to start decreasing now. So now we're going to start going down. And where do we stop decreasing? At that turning point again. So we are going to decrease from -4 to 0. Now once we get to the bottom, what do we do after that? We start going back up again. And we're going to go up until we get to infinity. So now we are back to increasing from 0 to a positive infinity. All right, so, I mean, increasing and decreasing, it's the same as it was before. There's no change. Now you just have more sections of increasing or more sections of decreasing. And so here's the thing, odd. Remember, odd is going to have different end behaviors. So we just look. As x goes to -infinity, that means as x goes left, what's y doing? It's going down. So it's going to -infinity. As x goes to the right, to positive infinity, what's the graph doing? It's going up into positive infinity. Okay? So again, end behavior, increasing and decreasing intervals, x-intercepts and y-intercepts, all that stuff, maximums and minimums. You have done all of this before. It's just now we're extending it to different types of graphs where you had a max and a min. So that's where we're headed. So now I would like you to pause this video. I'd like you to pause it and see how many of these you can answer on your own. And as soon as you're ready, click play and we'll see how you did. So this is even. We could also tell because of the fact that it's decreasing. Now this would be technically a -x⁴ graph, but this is not a very specific graph. This is just an example of a quartic type of graph. It's even. So one of the things you should notice is your end behaviors are both going to -infinity. So you might have done that part first. You never have to answer these all in order. Your x-intercepts. We have a -5, a 1, and a 6. So we have a -5, 0, a 1, 0, and a 6, 0. And I want you to pause for a minute. This is one of those examples that I was talking about. -5, 1, 6. That's only 3 solutions, but this is x⁴. And one of the things you're going to learn is that we have a bounce off of an x-axis. Whenever it crosses an x-axis, it's considered one solution. Whenever it crosses the x-axis, it's considered one solution. But whenever it bounces off an x-axis, it's actually considered a double root. So that's actually two solutions. So if you were to think about this, 6 actually has a multiplicity of 2. Now, if you were to write this as a factor, just to go back in time, that would be x plus 5 times x minus 1 times x minus 6 squared. And that's how you would end up with x to the 4th power. Of course, that's if we were doing this all fancy and pretty. But again, we're talking about the most important parts right now. We know that our y-intercept is 0, 5. We have 2 local maxes. We have one at -2, 9. And we have another one at 6, 0. So the maxes is whenever it's at the top and it's a turning point. Your local minimum would be 3, -5. Now I want to point something out for a minute. This is called the absolute max. And the reason why is a graph will never get higher than that point. In the last example, we didn't have any of those because it went to infinity, both positive and negative. But if we look at this graph, that's the highest this graph ever gets. That's known as an absolute maximum. Okay, so -2, 9 is known as an absolute max, but it's still considered a local maximum. Okay? And I guess the last step is increasing and decreasing. So you're getting used to these by now. Remember, you start at -infinity, and we're going to go to positive infinity in terms of x. Now, look where it increases. It increases from -infinity until we get to the top of that turning point at -2. And then it increases again from 3 to 6. So your increasing intervals are from -infinity to a -2, and then it increases again from 3 until it gets to 6. And your decreasing intervals is from this zone and that zone. And again, if it helps, you can split these by their extrema or their max and mins. So it decreases from -2 to 3. And then it decreases again from 6 and forever. Positive infinity. Okay? So again, remember, with increasing and decreasing, you are thinking in terms of x. I know it's going down into -infinity in terms of y. But in terms of x, going to the right is positive infinity. Okay? So that is a big old crazy lesson on some graph theory. But it's very important stuff that you need to know. But remember, a lot of this was review. So that's it for this one, guys. This is Longo, and I'm out. See you, bye.